So the element constraint is implemented inside the element one-dimensional constraint because you also have the two-dimension version of the element constraint, but it's out of the scope of this lecture. We have the array, the input array, the variable y, and the target variable z. And so this constraint is enforcing that array at the index y is equal to z. Okay, so this is what this constraint is supposed to do. This is the semantic of the constraint. So the first thing that you will do is sort the array T. Okay, so sort the array that is given input, the array of values. You will sort it increasingly. Okay, and you will sort and you will remember the permutation of the sorting. Okay, so you create an array from 1 to n, and then you will sort it, and so that you can retrieve the permutation of the values afterward. You will also maintain here the low and the up pointers exactly as it's represented here in the arrows. Okay, and what you will be interested to be notified, the event that you will be interested to be notified in, is the domain change in y, but the bound change on z, because if something changes in the middle of z, you can do nothing, because this is the relaxation that you will do. Okay, you will not achieve a domain consistency, so you are only interested to be notified when the bound of the z changes. And then you've got the propagate method, and the propagate method is pretty simple. It will simply try to see if the up and the down pointers are still supported values or not. And so you will start here between L and up, which are the values of low and up. And as long as at the index L you are supported, okay, as long as you are not supported, you remove the corresponding value from y and you update the pointer L. And you do the same for the upper pointer, you update it. And at the end, once you found two support, okay, for these two arrows here, once you found the two support, you can update the domain of z. And this is all what we need to do. And as you can see, it's really an incremental filtering algorithm, because you will always start from the current value of the two pointers, low and up. Okay, and so these two pointers down in the search tree can only get closer to each other. Okay, so like this. So this is the way we implement the element constraint, and this is again, it's a relaxed consistency. It's not the domain consistency. If you're interested to implement the domain consistency version of it, you can do it. And there is also a more complex version of the element constraint, where this array is an array of variables instead of an array of values.